Equations and units, practice number 5. Extract. Get the data out. I always write it on the top right hand corner. Choose a formula, best from memory. Okay, use your equation sheet. Check for units, substitute, solve, round, so that's the number of decimal places or significant figures. Put in the correct units. When an elephant is running at 15 meters per second, so that sounds like a speed, velocity of 15 meters per second, with a kinetic energy of, flipping neck, 281.25 kilojoules, what is the mass of the elephant? Right, so our formula is kinetic energy equals half the mass times the velocity squared. Right, units. Kinetic energy is measured in joules, so therefore I need to convert my kinetic energy, so 281.25 kilojoules equals times by 1,000, 281,250 joules. Right, now substitute in. This one's looking a little bit harder. So substitute it in. We've got 281,250 joules. Okay, it doesn't matter what the numbers are. All you do is just follow exactly the same pattern. So I'm substituting in. Equals 0.5 times the mass, we don't know it, times 15 squared. Okay, wow, that looks a lot more complicated than some of the others. I'm going to put a little line down there so I don't get it all confused. Okay, and I'm going to start doing it in green. Now what I'm going to do is I'm going to kind of break it up a little bit and do it step by step. So I'm going to have 281,250 equals 0.5, I'm not going to do anything with that yet, times by mass, times by 15 squared, which is 225. Then I'm going to do 281,250 equals half of 225 is 112.5 times by mass. And because I've got times on this side, I divide it on the other side. So I'm going to write 281,250 divided by 112.5 equals the mass. So therefore mass equals 2,500 kilograms. Wow, fantastic. So when a skydiver with mass 85 kilograms is free falling to Earth from 15,000, so distance is 15,000 meters, the gravitational potential energy is 12,495 kilojoules. What is the gravitational field strength? Okay, so let's look for our equation. Gravitational potential energy equals mass times gravitational field strength times height, okay, which I guess is the same as distance. Units. Gravitational potential energy, 12,495 kg equals 12495 times by 1,000 joules. Okay, so we've got 12495,000, this is annoying, equals a mass of 85 multiplied by gravitational field strength, which we don't know, multiplied by 15,000, which is the height. Okay, so what I'm going to do then is 85 times 15,000. I'm going to do that in my calculator. So it's 12495,000 equals 1275000 times gravitational field strength. Let's just block that off. Now because it's times on that side, it becomes divide on the other, so it's 12495,000 divided by 1275000 equals the gravitational field strength. Now I've run out there, right, but what happens is divide those and it becomes 9.8 newtons per kilogram. Okay, big numbers, bit of a pain. The power of a kettle is 3,500, so power equals 3,500 watts. How much energy transfer in time? 60 seconds, so it's got to be in joules. So my equation is power equals work done divided by time. Okay, that's in joules, that's in seconds, that's in watts. Substitute in 3,500 is my power. I don't know my work done, so I'm just going to put WD divided by 60. Because it's divide on this side, times on the other, so it becomes 3,500 times 60 equals work done. So the answer then is the work done, or the energy transferred, equals 210,000 joules. And the chances are what they'll do is they'll probably send to kilojoules, so divide by 1,000, so take 3 noughts off, 210 kilojoules. An elastic band with a spring constant of 0.8. So spring constant, pick out the data, 0.8. Extension is 12 centimeters. Okay, I can see that's going to be a problem. I want the elastic potential energy, okay, which is measured in joules. So I find my formula. So elastic potential energy equals half times the spring constant times extension squared. Right, now I can see that's 12 centimeters. So 12 centimeters equals 0.12 meters, because extension must be in meters. So potential energy is half, I'll do that as a decimal, just makes more sense to me, times spring constant times 0.12 squared. So let's then do half of 0.8 is 0.4, multiplied by 0.12 squared is 0.0144, which I've obviously used in my calculator. 0.4 times 0.014 is 0.00576 joules. Okay, all you got to do is just use the numbers. If you just use the numbers, then you're never going to have a problem, all right? Even if it feels like it's going to be silly. A block of copper with a mass of 3.5 kilograms. Specific heat capacity of 385 is heated from 26 to 75 degrees C. Calculate the change in thermal energy. So let's find our formula. Change in thermal energy equals mass times specific heat capacity times temperature change. Okay, so that's what we're after. Mass is 3.5 kilograms. Specific heat capacity is 385. Change in temperature is 49, because it's 75, take away 26. I then do that as a sum, right, and my sum comes out at 52,552.5, but 3 significant figures. Okay, so that's reading the question. So first 3 significant figures, okay, is there. So I'm going to have 5, 2, I look at my next number, which is a 5, which makes the 5 go up, 6, 0, 0. And my units, thermal energy, joules. A current of 0.2 amps, current 0.2 amps, flows through a lamp for 1.5 minutes. Okay, I can see where that's going to be already. 1.5 mins. Calculate the charge flow. So let's find our equation. Charge flow equals current times time. Time, 1.5 minutes, so 1.5 minutes equals 60, half a minute, 90 seconds. So current, 0.2 times 90 equals, so 18, the units of charge flow are coulombs. Right, so they're getting slightly harder, right? But just remember, just use the numbers. Whatever numbers are there, just use them, okay? And what it'll do, it'll come right the way through to the correct answer.